Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Heterogeneous catalytic hydrogenation, H2PT, proceeds by adsorption of the alkene onto the catalyst surface. The phase of the double bond that adsorbs determines the rate, and steric accessibility of the double bond phase is the key factor. Moving on to the next step. Identify the structures. Both A and B are 2-norbornene derivatives, bicyclo, 2.2.1, hept2Na, bearing a methyl substituent at the C1 bridgehead. They are stereoisomers differing in the orientation of the methyl group relative to the double bond phase. Moving on to the next step. In norbornene systems, H2 addition over a heterogeneous catalyst occurs preferentially from the IChO phase, less hindered phase. The endo phase is blocked by the 1-carbon bridge. And for the final step. In structure A, the CH3 group is on the IChO phase, pointing away from the double bond on the same side as the methyl at the bridgehead, i.e., the IChO orientation places methyl on the IChO phase. This means the IChO phase of the double bond is partially blocked by the methyl group, reducing access for the catalyst surface. In structure B, the CH3 group is on the endo phase, pointing toward the endo bridge side, leaving the IChO phase of the double bond relatively unhindered. This allows easier adsorption of the double bond onto the PT surface from the IChO phase. In A, CH3 is shown on the left wedge at C1 bridgehead. In norbornene numbering, C1 is the bridgehead adjacent to the double bond. If CH3 is IChO in A, it partially blocks the IChO approach to the double bond, making hydrogenation slower. If CH3 is endo in B, the IChO phase is more open, making hydrogenation faster. Structure A has CH3 in the IChO position at the bridgehead. The IChO phase of the double bond in norbornene is the phase used for hydrogenation. An IChO CH3 at C1 would hinder IChO phase approach to the C2 is equal to C3 double bond more than an endo CH3. Therefore AB in rate. However, the given answer is A, AB. This means structure A reacts faster. In A, the methyl is positioned such that the IChO phase of the double bond is more accessible, perhaps because in B, the methyl at C1 is oriented endo and causes steric compression that slows adsorption, or alternatively in A, the molecule has less overall steric bulk blocking the double bond phase used for catalytic hydrogenation. The critical point is that in A, the CH3 group at the bridgehead points away from the double bond's reactive phase, IChO phase for H2PT, so hydrogenation proceeds faster. In B, the CH3 group points toward or over the reactive phase of the double bond, hindering access to the PT surface. Therefore AB. Why other options fail? B, A is equal to B is wrong because the two stereoisomers have different steric environments at the double bond phase. C, B is wrong because structure B has more steric hindrance to the catalytic surface approach. D is wrong because both molecules contain a reachable double bond. Therefore, the correct answer is A. Therefore, the correct answer is option A.